calculus 1. Now we're going to do 3.5 limits at infinity. Alright, let's look at two definitions. The first definition is the definition of horizontal asymptote. Alright, the line y equal to L. I have a line, horizontal line here, y equal to L. It's a horizontal asymptote of the graph of f if limit as x go to negative infinity, f of x equal to L. So as x go to negative infinity, the y or f of x go to L. Or limit as x go to infinity, f of x equal to L. As x go to infinity, the f of x or the y go to L. Let's look at the next theorem. Alright, theorem, let me move this way. Theorem 3.10, limits at infinity. We have if r is a positive rational number and c is any real number, then limit as x go to infinity, c over x to the r equal to 0. Think of c is any real number and x to the r is infinity, then we divide a real number by infinity, we should get 0. Furthermore, if x to the r is defined and x is a negative number, x approaching negative infinity, c over x to the r also gonna get 0. Let's take a look at next definition. Alright, guideline for finding limit as plus or minus infinity of rational function. The first one, if the degree of the numerator is less than the degree of denominator, then the limit is 0. Look at this first example. Find the limit as x approaching infinity of 2x plus 5 over 3x squared plus 1. The degree of numerator is 1. The degree of denominator is 2. From this, we know that the limit is going to be 0. However, I will show you how I get 0. Let's look at this function. I'm going to divide both numerator and denominator by x squared. Usually I like to divide by the highest degree of denominator, which is x squared. So I would have 2x over x squared plus 5 over x squared for the numerator. Now for the denominator, I would have 3x squared over x squared plus 1 over x squared. I divide every term by x squared. Let's reduce this. The first term, the x cancel the x, so I left with 2 over x. The second term is just 5 over x squared. On the denominator, the first term, the x squared, cancel the x squared. I have 3. The second term remain the same. Alright. Now as x go to infinity, the first term will be 0. The second term will be 0. So we have 0 on the numerator. Denominator, we have 3. On the second term will be 0. 0 over 3 is 0. So this whole thing is equal to 0. The second one, if the degree of the numerator is equal to the degree of denominator, then the limit is the ratio of the leading coefficient. Look at this example. The degree of numerator is 2. The degree of denominator is also 2. And we should get the limit is the ratio of leading coefficient. The leading coefficient of numerator is -4. The leading of the leading coefficient of denominator is 1, so the answer should be negative 4. One way to doing this, you can do similar thing that we did in the first example by divide everything by x squared on each term. That you're gonna get negative 4. Or because I have only monomial on the denominator, I'm gonna break it down into 3 terms. That will be much easier. Let's take a look. So I'm gonna have a limit as x go to infinity. I'm gonna rewrite this as negative x squared over x squared plus 2x over x squared minus 5 over x squared. Alright, this separate 3 different terms. Then I would have limit as x go to infinity, the x squared cancel. I left with negative 4 plus 2 over x minus 5 over x squared. Now as x go to infinity, the second term will go to 0, the third term will go to 0. And we will have the answer is negative 4. That's the definition set. Alright, negative 4 over 1 is negative 4. Let's look at the third definition or guideline here. If the degree of numerator is greater than degree of denominator, then the limit does not exist. Okay, look at this rational function. The numerator has degree 3, denominator have degree 2. So the degree of numerator is bigger than degree of denominator. Then the limit does not exist. Let's do this example. I will divide both numerator and denominator by x squared. Then I would have limit as x go to infinity, 2x to the cube over x squared plus 5 over x squared. That's only the numerator. The denominator, I would have x squared over x squared plus 1 over x squared. I will simplify this. I will have limit as x go to infinity. The first term I would have 2x. The second term I would have 5 over x squared divided by 3 because the x squared cancel out, plus 1 over x squared. Now as x go to infinity, this term will be 0, this term will be 0. I would have infinity because x go to infinity. Infinity times 2 is infinity over 3. So the numerator go to infinity, denominator is approaching 3. The answer would be the limit does not exist. That's the notation for the limit does not exist. Let's look at example. Hi everyone, let's look at our first example. Limit as x go to negative infinity, right, of this function. So I'm going to divide both numerator and denominator by x. The numerator divided by x, that's not a problem. Denominator, we have square root of x squared plus 1. Now I want you to look at this one as x less than 0. If you square any negative number, it will be positive, and then you take root. It's going to be positive, but you have a negative here, so it's going to be negative, right? So my x, I want to make sure is negative, right? So we're going to divide numerator and denominator by x. The numerator, I'm going to have negative 3x over x plus 1 over x. That's my numerator. My denominator, I'm gonna have square root of x squared plus x divided by this one, which is x, minus square root of x squared. Let's simplify a little bit. Then I will have limit as x approaching negative infinity. The numerator, I have negative 3 plus 1 over x. On the denominator, I will have negative square root of x squared over x squared plus x over x squared. I'm gonna simplify some more. Then I will have limit as x go to negative infinity, negative 3 plus 1 over x on the numerator. On the denominator, I will have square root of x squared just 1 plus 1 over x. Again, from the definition that I gave it to you earlier, this term will become 0, this term will become 0. Then I will have negative 3 on the numerator, and square root of 1 is just 1. I will have negative 1 on the denominator, which is 3. Let's go to the next one. The next example, I will divide both numerator and denominator by x to the cube. So for the denominator, there's no problem, x to the cube. Now you have to think, on the numerator you have square root of x to the 4th. Now as x is negative, alright, if x is negative, if you raise it to the 6th power, it's going to be positive. Take root of it, it's going to be positive, but because we have minus here, it's going to be negative. So I want to make sure that my x is negative. Let's divide everything by x to the cube. I would have the numerator would be square root x to the 4th minus 1 divided by this term right here. That is my numerator. Denominator, I just have x to the cube minus x to the cube minus 1 over x to the cube. Next step, I'm gonna simplify a little bit. Let's see, I'm gonna divide the board a little bit, so just to make sure I have enough room. So this one, I'm gonna have limit as x approaching negative infinity. I'm gonna have negative, this whole thing gonna be x to the 4th over x to the 6th minus 1 over x to the 6th for the numerator. The denominator, I would have 1 minus 1 x cubed. Let's continue to the next board. So I'm gonna have limit as x approaching negative infinity. If I simplify this, I would have square root of x to the, I can reduce, so it's 1 over x squared actually, minus 1 over x to the 6th. The denominator, I would just have 1 minus 1 over x cubed. So as x go to negative infinity, I would have 0, negative 0 is just 0 on the numerator. This term will go to 0. Then I will have 1 on the denominator, which is, I forgot the minus, which just doesn't really matter. Then I would have 0. Alright, let's go to the next example. Now let's look at the last two examples. Example 3, I have limit as x go to negative infinity of 2x over x to the 6 minus 1 to the 1/3. If you look at x to the 6, x raised to the 6th power to the 1/3, actually is x squared. So I'm going to divide both numerator and denominator by x squared. The first term, I reduce the x, so I left with 2 over x, and I divide the denominator by x to the 6th raised to the 1/3, which I can combine them. And then reduce, then I would have 1. And as you take a limit as x go to negative infinity, you would have 0 on the numerator, 1 for this term, 0 for this term. So 0 over 1 is 0. The next one, I'm just going to show this for you one time, and you can always use it, alright? Limit as x go to negative infinity of sine of x over x will always equal to 0. So from the unit circle, you know that sine of x is between negative 1 and 1. And if I have x greater than 0, I divide every single term by x. And then I take limit for the first term and the second term. The limit of the first term is equal to 0. The limit of the second term is also 0. And by the square theorem, limit as x go to infinity, sine of x over x is equal to 0. You can memorize this. Alright, until I see you next time. Bye.